Okay, folks. So today I want to focus on one topic primarily and do a little demonstration on this topic in code. And it's a fun word in my opinion, right? So it kind of stems from Latin, right? Poly is many, morphism is forms. So polymorphism kind of means many forms, and so translated polymorphism stands for many forms in English. And so what does that mean in code? Well, that's going to be what we explore today. What is polymorphism in code? What does it mean to take many forms in our C# code? And polymorphism is what every time I cover this topic, I kind of go back to what's considered the pillars of object-oriented programming. And so you can kind of Google search what are the pillars of object-oriented programming. In other words, what are like the main structural foundation of OOP? And you can kind of see just at a high level, encapsulation is a term we haven't really talked about encapsulation, although we have practiced it. The idea of encapsulation is, to encapsulate something or to contain something in a storage unit. And so when we're making classes, which we started doing last chapter, what you're doing in a class is you're encapsulating all of the attributes and all of the methods for that thing. And so it's kind of like bundling up or packaging all of the belongings into a container. And so when it says encapsulation, basically that's you're making classes. A pillar of object-oriented programming is you have classes. Those classes encapsulate attributes and methods for that thing. Okay, so that's encapsulation. Yesterday, for the first time, we covered inheritance. Yes, you have classes. Those classes encapsulate things. But then these classes also are related. They have parent and child relationships, and they can inherit non-private members. Okay, so another pillar, right? So one pillar is that you have classes, aka encapsulation. Another pillar is that those classes inherit from one another, and so you're not rewriting code necessarily at the same extent that you would have otherwise, right? And then the third pillar is what we're going to focus on today, is this concept of polymorphism, which means many forms. And so, when we're talking about classes and objects, we're talking about inheritance, and then we get this fun little word that means many forms, but really what does that mean in code? And that's what I'm going to demonstrate. Okay, so this is a very important pillar, just as classes and objects and just as inheritance. So let's get into the demonstration. I'll just start off by spinning up a Windows form project and polymorphism demo. Okay, and yesterday when we started talking about inheritance, we drew up a very simple diagram of an inheritance tree where you've got a class called animal, and then underneath animal you have two children, be it a dog and a cat. Of course, this could be extended, across the whole animal kingdom if you wanted to, right? But we're just keeping it with our house animals, everyone's favorite dog and cat. So if I were to code this, very quickly, I would make a class called animal, and what are the properties of animals? So I would say, well, again, I can go with a number of eyes. Our animals have a number of eyes, and maybe legs for an int. and maybe their Latin name. I don't know their name in Latin. These are properties, so we'll just do this. And so you've got some properties, and we're not really going to dive into those properties very much. But what might an animal be able to do? Well, at some way, you know, an animal is going to be able to move. So this is like a behavior, right? So a method would be a behavior. And so you've got properties, which are data attributes that you're collecting on your animals. And you've got a method here called move, where maybe this just returns a string, and it'll just say return the animal is moving. Okay, so I might come back to this class, but it's real basic class for right now. And this class is going to serve as a parent class. Now, to our child class, which will be cat, we'll mark it as public. And we learned yesterday to inherit from animal, we just do :animal. So cat is the child, animal is the parent. You might call it animal the base, and cat is the derived. We're going to do the same thing with dog. Add a class called dog. And we are now inheriting, so that if we were to instantiate a dog or instantiate a cat, that they would have these 4 public members available to them. We also covered yesterday that as you go down the inheritance chain, you go from up top more general to down below more specific. And so we have this method called move, that if we did instantiate a generic animal, that the generic animal would move like this. But sometimes you want to implement more specific methods or implementations of a method. For example, a cat might move differently than a dog. You might want to overwrite that behavior. And so if I were to write this method signature, if I were to write this same method signature here and try and overwrite that, let's go ahead and say return the cat bounces around. You kind of get this little green squiggly. And it says cat.move hides inherited animal.move. Use the new keyword if hiding was intended. And so hiding kind of means, well, you lose access to the parent's implementation of move. And so when you don't typically want to hide a method, and so you can mark this as virtual. And then that allows you to call base.move, and that way it's not hidden. So when you, basically what virtual does, it says a child class can override this method. Okay, so it is common to mark a method as move if you're going to override it in a child, and then you can do override. Right? And now we have a more specific implementation. And if we wanted to call, base.move plus, and this would be like this, we're not hiding the parent implementation of move. Okay, but we really don't need to call base.move. We're just going to override it like such. Okay, and let's kind of go into the dog, and let's override move as well. And return the dog lays there. The dog just lays there. It's an old dog, what have you. So let's not delete an extra curly so we get our curlies all lined up. So to set this up, like this is kind of common, like you're gonna have methods in parent class, and then you might wanna write more specific implementations of those methods in the children. And so if we were to just demo this on a button click, I'll call this button demo. And we'll get a label result. And so what I'm going to do is I'm going to make a cat, C1 equals new cat, using the default constructor. And I'll say label result.text equals C1.move. And you can see, as you might kind of guess, how this is going to polymorphism demo. Says the cat bounces around. That's what you would expect since we have a cat object. If I instead look at my dog, D1 is new dog, and I say D1.move, of course when I call the move method on the dog just lays there. That's probably what you would expect. I think that just makes sense. When you have a cat object you call move, the cat does one thing, the dog does something else. And really there's not too much new at this point other than we're actually overriding a method that we wrote. We have overridden a method before. We have overridden the toString method, right? toString is a method that's inherited from the object class. Remember that all of our classes, be it dogs or cats or animals, have an implicit. I believe Connor yesterday kind of was asking about this object class, right? Now notice I don't explicitly inherit from object because you get that automatically. So animal automatically inherits from object. That's where we get toString from. toString is passed down from object. We inherit that method, and then we would override it inside of animal. So we have overridden methods before. We just haven't overridden methods that we've written, right? Now I've written a method inside of animal. I've marked it as virtual, basically saying that you can override it, and then you're not hiding the parent implementation. And then I went ahead and overrid it in the cat and the dog. And of course, going back off of what we learned yesterday, because cat inherits from animal, I could set the number of eyes equal to 3, the num legs equal to 1, and the Latin name for this particular cat, I don't know any Latin names for cats, but blah blah. Okay, so we get these properties because of inheritance. We get the method because of inheritance, even though we've written a more specific implementation. So let's show you something new, right? Nothing new yet, okay? There is something in C#, again, it allows us to write more efficient code called, and there's different names for this, but the name that I remember and prefer is called upcasting. Okay, what is casting? Casting is another word for converting. So what have we done, like since day 2 in this class, is we've converted data types. We've taken strings and converted them into ints. We've taken doubles and converted them into strings. We've taken this type and converted it to that type. And so, spoiler alert, if you get into this industry, you are converting data types all day long, all the time. It is just very common to have to work with data and convert types. Okay, so you're always working with data types and you're always converting with them. So the word cast is another word for converting types. We are converting from one type into another. Upcasting means you're taking a child and converting it up into its parent. You're going, what? A child up into a parent? Let me demonstrate this. Okay, let me demonstrate this. Now, syntactically, 14 and 15, you've seen these lines all the time. What's on the left is the same type that's on the right. What's on the left has to match the right. And that's been the rule so far. Something on the left has to match something on the right. If it's an int on the left, it's an int on the right. If it's a double on the left, it's a double on the right. Hasn't worked otherwise. You've gotten squiggly lines, right? This is the first time that we're going to learn in this class that rule actually it's going to change a little bit here. I'm allowed to say animal A1 equals new dog. What in the world? This is upcasting. This is upcasting. What you have on the right is a dog, and it's casting up into any type that is its parent, up the chain. Okay? So again, what this is upcasting. I'm going to show you how it allows us to write some pretty interesting and efficient code. Okay, so upcasting means you could take any child, and convert it up into its parent. Now, if I were to call a1.move, you're kind of, if you're guessing at this, is it going to be the animal move or is it going to be the dog move, right? You just got a 50-50 chance. It's probably not going to be the cat move, right? But if you had to take a guess, what is your guess? Go ahead inside your head, take a guess. And, well, there you get the answer. You're getting the dog move version of this method. Okay? So you can cast a dog up into an animal because it is up the inheritance chain. Okay? Now, I get to show you how this is beneficial. Because right now, like the first time I saw this, if you were like me, it's a head scratcher. Because again, the data types have always matched on the left and the right. And this is really the first time that we haven't seen this. Okay? Yep.
This is like completely like pointless to ask, but like you can't like move it into the cat's area or
no, because those are siblings. Like you can't take a dog into a cat or anything. Yeah, you can only go up the inheritance chain. Yep. So how is this relevant? Well, it allows us. Let's do this. Let's have a list of animal. Animal list equals new list of animal. Now right now we've got basically two children of animal, but again, you could expand this out into the whole animal kingdom if you wanted to. Okay? So we have a list of animals. And in that list, let's put, because we just learned that we can upcast a new dog in our list of animals. And our dog will have a number of eyes of 2, num legs of 4, Latin name of blah blah, and let's put a new cat. We can have a list of a parent type, and then any valid child type could be stored in that list. That's kind of interesting. So we could say this cat has 3 eyes, 5 legs, Latin name of ALB, whatever. Okay. Now, I can write a method that accepts. Let me write a method here. It's going to be a private method. It's going to be void Well, let me before I write this method, okay? Let me demonstrate. If I say label result dot text equals animal list sub zero dot move. Okay, animal list sub zero is a dog, and when a dog moves, the dog just lays there. And if I do animal list sub 1, well, it's sub 1, that's our cat, and we get the cat bounces around. So, okay, we have a list of animals, and in that, any child is a valid list item. And then depending on the subscript that we use, we're actually calling a different method. This right here, line 20, is my favorite example of polymorphism. This move method, and I guess I could make one small change because I do have to change the code. But this one line of code, this one move method, behaves differently depending on the object that it references. Let me kind of write that down. This line of code, this move method, behaves differently based on the object that it references. If the object references a cat, you get one behavior. If it references a dog, you get another behavior. Okay, I'm actually jumping the gun a little bit. I can demonstrate this a little bit better. But this demonstrates polymorphism. Your one line of code is going to behave differently based on the object that it references. Now, I don't like this because my one line of code, I have to change it. Okay, I'm going to actually write a method, and then I don't have to change my line of code. I'm going to get this polymorphism. Again, I'll get a line of code that doesn't have to change, and it will not change, yet it will behave differently in different scenarios. Okay, the problem with my example right now is I'm literally changing the subscript, thus changing the code and getting it to behave differently, right? So when I was learning this polymorphism, this idea of move, is an action, okay? And the action is a different action depending on the object, okay? And I always remember this example, so if you guys kind of zone in with me here, okay? The action is different depending on the object, right? And I just did that. The move action is different depending on the object. The book example that I remember, and I always, the action of playing something, right? Playing the guitar, okay, the object is the guitar, and what it means to play the guitar, is vastly different than playing basketball, right? Play is the action. Depending on the object, a guitar or a basketball, you're getting very different behaviors. Okay, that's polymorphism in the real world, right? The action is different depending on the object. I just demonstrated that a little bit in code. The action, move is the same action. You just get a different behavior depending on the object. Yes.
Now, say dog didn't override the move. Would it just go off?
It would go off of animal.
Okay.
It would be whatever the animal does. Okay? So that is the definition of polymorphism, and this is it in code. I want to just make one little tweak to this because what I'm doing here is I want to make a method that accepts an animal. So I'll say private void, and I should give it a good name, do something. Not a good name. Okay, so notice my parameter is an animal, and I'm just going to say label result.text equals a1.move. Now, if I call do something and I pass it animal list sub 0. Okay. Now this line of code is completely polymorphic in nature. Okay? If I pass it a dog, I get one behavior. If I pass it a cat, I get another behavior. If I pass it a rhinoceros, I could get another behavior. The move method behaves differently depending on the object that it references. Okay? And that's polymorphism, and this is a polymorphic, polymorphism in code.
You can use this in a for each loop, right?
Yeah, so you could use this in a for each loop. So let's do this, right? So let's loop through our animal list for I less than animal list dot count, and let's call do something, passing it animal list sub I. Okay, so the first time I send in a dog, the second time I send in a cat, and I tell them both to move. The dog just lays there and the cat bounces around. Okay, notice this is the most clear example of polymorphic behavior that I can give in code. That line of code does not change, yet you behave differently. The code, you get different output of the code depending on the object that you pass in. The first time I call do something, it passes in a dog, so I get one behavior. The next time I pass in a cat, so I get another behavior. Okay? So when you have classes are going to have some inheritance chain. You're going to work with inheritance. Many, in object-oriented programming, it's a pillar. You have classes, fundamental, you have inheritance, and then when you have inheritance, you can get some different behaviors out of your code when you start doing this upcasting, right? So you don't have to write one method that accepts a dog and another method that accepts a cat and another method that accepts a rhino. You write one method that accepts an animal. You can pass anything into it, any sort of child object into it. It does have to inherit from that. And then you can call on the various methods. Now, if dog has a more specific method, like what is something that a dog does that something else doesn't? Void, fetch. Most cats don't fetch, right? Anybody have a cat that fetches? Some people say, "Oh, my cat acts just like a dog. My cat will fetch." People always, yeah.
Q-tips.
They'll fetch Q-tips.
Only Q-tips.
So let's just say that a dog fetches, and the dog fetches a bone, right? Most cats don't. Most cats don't do that. Okay, so now our dog class has a unique method that doesn't exist in either animal or cat, and you'll kind of come back here because this animal A1. Because this is an animal, you don't have access to fetch because, again, that doesn't exist in animal. It only exists in dog, right? So that's kind of the limitations, is that you can't call on those specific methods that only exist in the children class, but you can call the methods that exist inside of animal that have been overridden.
Even if you would do animal sub 0, it wouldn't.
Oh, up here you could. Here you could, but notice in this method you cannot.
Okay.
Right? So, yeah, if I were to bring that back, if A1 dot move, but kind of back here, if I were to say animal list sub 0 dot, notice that this is still an animal. Actually, no, you can't.
Okay.
because this is a list of animals. So you can't say animal list sub-zero dot fetch. Unfortunately, that is not going to work. So you are kind of constrained when you do that way. So that's polymorphism in code, and in your lab, I believe it's the first lab in chapter 14. You're making letters and certified letters and storing them in a list, kind of like we did here, a list of the parent object, right? So you can store both letters and certified letters in a list of letters, kind of thing. So this kind of concept, the concept of upcasting, that will help you with your lab.